So yesterday you learned about the standard form of a linear equation, which is the ax plus by equals c. And that type of equation can be used to write an equation in two variables. So today you're going to see how that equation written in two variables can be used to solve a system of equations. Below we have, to use the elimination method, we're going to first determine if there is a pair of x or y coefficients that are opposites. If there is, you're going to go to step 2, and if there's not, you're going to multiply one of the equations by a number that will make the equation have an opposite coefficient for one of the variables. Second, you're going to line up the equations vertically and combine like terms so that either the x values or y values cancel out. Third, you're going to solve for the remaining variable. Fourth, substitute the answer from step 3 into each equation to find the solution for the other variable. And fifth, write the final solution as a coordinate x and then y. So this is similar to when we did systems of equations, but we dropped the y's and set them equal to each other. That's called substitution. Now we're going to be getting rid of a variable to solve for one variable. That's called elimination. I'm going to do the first two examples with you. Then you're going to try the next two on your own. And then I'm going to do the last 4 more difficult ones with you as well. So here we go. First one. So these two are pretty easy because there are already opposite variables or opposite coefficients with one set of the variables. So if we look at number 1, we have 2x plus 5y equals 22 and x minus 5y equals negative 19. So the positive 5 and negative 5 are opposites. Therefore, the y's have opposite coefficients, and we can go right through the process of eliminating that. So we can draw a line underneath to show that we're going to be adding these two equations together. 2x plus x is 3x. Positive 5y and negative 5y cancel out. And 22 minus 19 is 3. So now we have a very simple equation that we can solve. 3x equals 3. We divide both sides by 3. And x equals 1. So now we have one of the variables, and we just have to solve for the second variable. So I'm going to substitute x back into one of the two equations. I'm going to use the top one. So we have 2 times the 1, which we just solved for, plus 5y equals 22. So 2 plus 5y equals 22. Subtract 2, and 5y equals 20. Divide by 5, and y equals 4, making our final solution 1, 4. Remember, when we're writing a solution, it's always the x part of the coordinate first, then the y. Taking a look at the second problem, again, this one's very simple because we have a pair of opposite coefficients. In the last one, the opposite coefficients were the y values. In the second one, the opposite coefficients are the x values. So we can jump right into adding these two to eliminate the x's. 3x minus 3x cancels out. Negative 7y plus 8y is 1y, or just y, equals negative 27 plus 30, which is positive 3. And look at that. The equation is already solved. So we have y equals 3, and we can substitute that back into the equation to solve for x. So 3x, I'm going to use the top equation, minus 7 times 3 equals negative 27. So that's 3x minus 21 equals negative 27. Add 21 to both sides. 3x equals negative 6. Divide by 3. And x equals negative 2. Making our final answer for our solution to this system, x first, negative 2, then y, positive 3. So right now you're going to pause the video and try numbers 3 and 4, and then come back for 5 through 8. Okay, so 5 is much more challenging because we don't have a pair of opposite variables right away. What we do see is that we have 1 plus and 1 minus. So it might be easiest to try and make those two opposite pairs. In order to make those two opposites, Since the bottom one is -2, I'm going to multiply the top one by +2 to get a positive 2y and a negative 2y together. So I'm going to rewrite the whole system. So this top equation, I'm going to multiply by 2. Everything in that equation gets multiplied by 2. So 2 times 4x makes 8x. 2 times positive y makes positive 2y. And 2 times 8 makes 16. Then I'm going to bring the second equation down underneath it and start to solve. So now I have a pair of opposites, and I can start adding them to eliminate the y's. 8x plus 5x makes 13x. Positive 2y and negative 2y cancel out. 16 and 23 make 39. Divide by 13, divide by 13, and x equals 3. Now I have to take that x, plug it back in to solve for y. So I'm going to plug it into the first original equation. So 4 times 3 plus y equals 8. So 12 plus y equals 8. Subtract 12. And y equals -4. Making my solution 3 for x and -4 for y, or 3, -4. So there's a little bit more work involved in these just to get that first step where the two variables are opposite so we can eliminate them. So in that case, we eliminated the y. Let's take a look at number 6. 5x minus 6y equals 20 and 4x plus 2y equals -18. So in this case, we're going to go right into eliminating a variable. So again, in this case, we have a pair of opposites, the negative and the positive right here. So it would probably be easiest if we can make those two opposites. And we know that 2 goes into 6 very easily, so we're going to take the bottom equation and multiply it all by 3. Then we'd have 6 and -6, which will cancel those out. So we start by rewriting it, bring this top equation down, because we're going to leave that one alone. Then distribute the 3 to the second equation, which gives us 12x plus 6y equals -54. And now we can start to solve and eliminate the y's. 5x plus 12x is 17x. 6y and -6y cancel out. 20 minus 54 is -34. Divide by 17, divide by 17, and x equals -2. Now we can plug that back in and solve for y. So 5 times -2 minus 6y equals 20. 5 times -2 is -10. Minus 6y equals 20. Add 10 and add 10. -6y equals 30. Divide by -6. Divide by -6. And y equals -5. Making the solution to this problem -2 for x and -5 for y. Okay, so now 7 and 8, add another spin to this. Remember back when we did equations that have one solution, no solution, or infinite solutions? So all the ones we've solved up until this point have one solution because we were able to find one coordinate that satisfies both the equations. When we look at 7, 8, we're going to see that there can also be infinite solutions or no solutions depending on the system that's given. So taking a look at 7, we have 3x and -8y equals 15, 9x and -24y equals 45. So if I look at this and I try to make an opposite pair, something I could do here is multiply the top equation all by -3, because that would give me -9, which would make the 9's cancel out. So I'm going to bring the top one down, -3 times 3x, -3 times -8y, and -3 times 15. So that gives me -9x plus 24y equals negative 45. I'm going to bring the bottom equation underneath it, positive 9x minus 24y equals positive 45. These look awful familiar. So now when I go to solve this, wait, the 9x's cancel out, the 24's cancel out, and the 45's cancel out. So what happens here is I get 0 equals 0. These two equations are infinite. 0 equals 0, that means there are infinite solutions. If I had decided to just multiply the top one by positive 3 instead of negative 3, I would have had exactly the same equation. So they are the same equations, therefore there are infinite solutions. Number 8, if I go through this idea the same way again, take a look at those two equations. I could multiply the top one by negative 2 to get negative 4x and positive 4x. That would give me negative 4x minus 14y equals negative 60. And then underneath, positive 4x plus 14y equals positive 30. So now when I go to solve, the 4x's cancel out and the 14y's cancel out, so I get 0 on this side, but negative 60 plus 30 gives me negative 30. So in this case, 0 does not equal negative 30, so there is no solution. So those two equations are not exactly the same. Their answers are different. Therefore, there is no solution. Symbol for that being a circle with a slash through it. I forgot to draw the infinite symbol before, but I think most of you guys remember that. So there you have it. So now you're going to go ahead and answer your exit ticket, and you can start your homework if you have some time left over.